Hello, Revit users. My name is Alfredo Medina. I work at HHCP Architects, an Orcat Winslow company in Orlando, Florida. I am a member of the Autodesk Expert Elite Group. In this video, I want to demonstrate how to create a simple parametric model family in Revit. This table I will be using a workflow, this sequence of steps, and I will be using Snagit for my notes. And on the left, you see that I'm using Revit 2023. You may want to use an older version for your families, usually some 2 years before the current version. To begin, we do this families, new, and our first decision is to choose a template. Then I go to family templates, English Imperial, and I find furniture for this table. Then the family editor opens, showing the reference level or plan view. Before creating a skeleton of references, we need to establish the origin or insertion point of the family. Let me explain this. In this scheme, this is the most typical origin for a furniture family. You may want to do it like this in some cases, so that the origin of the family is the upper left corner, or maybe the lower left corner. But definitely don't do this. Don't do any random location. The preferred origin is centered at the intersection of the reference planes. Then let's start creating our references. We start by creating references in plan view to control this dimension, the total width, and this dimension, the depth. For example, we need one reference plane here, another one over here, and another one here, and another one here. This will control the width and depth of the family. So let's do that. In Revit, we do create reference plane, and we draw two reference planes in the vertical direction at any distance, and two reference planes on the horizontal direction, like this. Click on Modify to finish or cancel. Then, because we said we wanted to be equal in relation to the reference planes, we put the first dimensions like this, annotate, aligned, and we do this. Click here, click here, click here, equal, and then another dimension in the other direction, and then equal. And then to control this width, we create another dimension like this, aligned from here to here, and another one from here to here. This dimension needs to be parametric because we want to obtain different types. Then we click on this dimension and click on Create Parameter, and create our first parameter, such as width. We don't want the family to be flexible in the project, but just driven by types. So we make it a type, not an instance. Let's click OK. And we do the same for this other dimension. Convert into a parameter called def. And this is going to be a type as well. Click OK. Then looking at the picture, we need something to constrain the thickness of these legs. For example, in Snagit, that means that we will do a reference plane here, another one here, another one here, and another one over here, so that we have control over the thickness of those legs. Let's do that in Revit. In Revit, we do create reference plane, and we can use pick lines, and let's suppose that we use 2 inches. Well, actually in the picture it says that it is 1 3/4 that thickness. So let's enter 1 3/4, and we do this. 2 verticals and 2 horizontals to control the thickness of those legs. Does that thickness of the legs, does that need to be parametric? Usually no, but of course anything can be parametric. But let's say that we're not interested in putting a parameter to those dimensions. So when something does not need to be parametric, you can simply put a dimension and lock that distance. So this is always going to be 1 3/4. So use the path lock. So I lock these 2 horizontals, and then I lock the 2 verticals like this. Okay. Now it would be good to enter these values. Notice that I have inches in my sample image, but the template came with feet and inches. It would be simply more comfortable to use inches in this case. So let's do this. We go to Manage, Project Units, and change the units to be inches. Length, click here and change to fractional inches. Click OK. Click OK. And then now we can enter these values. The width is 35 and a half. So let's do that. Modify, family types, and we enter for the width 35 and a half, and for the depth we enter 21 3/4. 21 3/4. Okay, let's click OK. And now this is the initial or default width and depth. If you see that the dimensions are too big on the screen, simply come here to the list of scales and notice that we are using 1/2 inch. I usually go 2 steps up on that list to reduce the size of the text like this. Now that we have put constraints in the reference level view, I need to go to one of the elevations to work on the height. So let's go to the front elevation, for example, and here we always see this reference level. I'm going to drag the end of the reference level here because I don't want to take dimensions from the reference level to constrain my height. If you do that, then the family won't work properly. Always take dimensions from your reference planes. Okay, so coming back to the image, we see that the height is 17 and 3/4. So we can create a horizontal dimension to control the height at any height. Then we can put the actual dimensions. And there is also a thickness for the top board, and we need to have something to control the top of the shelf and the thickness of the shelf, like this. Now, does that thickness, the thickness of the shelf, does that need to be parametric? I don't think so. It can, but I would say no. Does that, the thickness of the top board, does that need to be parametric? Maybe not, right? So we can put locked dimensions for those two things like this. Annotate, aligned, and let's put a dimension to control this. And let's say that this is 1 3/4, and that needs to be a locked dimension. And this one is 3/4 of an inch. So we do this, annotate, aligned, this one to this one, and select one of them and enter 3/4 of an inch. And we lock this dimension. Let me reduce the size of the text like this. We are working in 1/2 inch, then we move 2 steps up to 1 inch like this. Now I would like the total height to be parametric. Yes, that would be useful. And also the height of the shelf in relation to the level. Yes. So let's create those two parameters like this. Annotate, aligned, from the reference plane, not from the level. From the reference plane, I measure the top height, and I measure also the height of the shelf, like this. And then we convert these dimensions into parameters. Select this one, create parameter, and we can call this height of table or simply height. And we want this to be a type parameter. And this other dimension, select and then create parameter. This is the height of the shelf. Okay, it's a type, and let's click OK. Now we enter the actual values or default values. We go to family type and we enter, for the height of the table, we enter this 17 3/4. So 17 3/4. And for the height of the shelf, we enter 8 inches. 8 inches. And click OK. So these are the actual dimensions. Notice in our workflow, we created the references, and we also created dimensions and constraints. Some of them were locked and some of them were converted into parameters. The ones that don't need to be parametric are simply locked. And then our next step is to test or flex if these values work correctly. To do that, we go to family types and we can test the height values here. For example, if the height is 21 inches instead of 17 and 3/4, we can enter 21 and click apply. And we see that the height changes and that this thickness remains constrained to 1 3/4 of an inch. And we can do the same for the top of the shelf to be, for example, 10 inches, apply. Yes, it is working correctly. So I can cancel these changes and undo 1 and 2, and now I get my default values again. In the floor plan, I can test my width. Let's suppose the width is 40 inches. Apply. Yes, it works, and the legs remain constrained to 1 3/4 in all cases. And the depth, let's suppose the depth is 24 inches. Apply. Yes, it is working. So now we can proceed to do the geometry. Instead of canceling and doing undo, I can simply type the default values again, such as 21 3/4 for the depth, and for the width, 35 1/2. I can rearrange the order of these parameters if I want to. By default, they follow the alphabetical order, but if you prefer a different order, you can use these options to move those parameters up or down, etc. Okay. Now that we have the skeleton created and we have tested that it moves correctly with the parameters, we can create the geometry of the table using the reference planes to constrain the geometry. This family contains basically 3 extrusions. One extrusion is the shelf, another extrusion is the 4 legs, and the other extrusion is the top. So let's create, for example, the top of the table like this. Create extrusion, rectangle, and I simply go from this intersection to this intersection and click to finish. Notice that I don't need to lock those lines to the reference planes because the reference planes are already constrained and I am going from one intersection to the other. So I finish, and then I go to a front elevation and adjust the extrusion to the corresponding reference planes. This is one way to do it. Another way or another option is to give a name to this reference plane, for example, and set that reference plane as my work plane before creating the extrusion. In this case, I didn't do that. I just used the default reference level as my work plane. So the extrusion is created from the floor. And then I need to do this. I drag this plane to the reference plane and lock. And I drag this plane of the extrusion to this reference plane and lock. The other method is that you, for example, you create a name for a reference plane like this, such as bottom of shelf. And then to create this extrusion, you go to the reference level. Usually I hide the previous extrusion like this. Click on the extrusion, glasses icon, hide element, and then I do this, create, set work plane, And from this list, I select the bottom of shelf and click OK. Now I can do the other extrusion. Extrusion, rectangle. Notice that the, the shelf goes or is aligned to the interior face of the legs. So it goes from this intersection to this intersection. And because I am using intersections of reference planes that are already constrained, I don't need to lock these lines. I click on Finish. And then I go to the front elevation and notice that this time the extrusion began here at the bottom of shelf because that was the work plane for my extrusion. Then I drag the top plane of that extrusion to this reference plane and lock. Then I go to my reference level, hide the new extrusion, and do another extrusion for the legs. To do that, I go to Create, Set Work Plane, and I select the default reference level again to begin from the floor. To do the legs, I do this extrusion, rectangle, from this intersection to this one, from this one to this one, this one to this one. The order doesn't matter. From here to here, and finish. Then I go to the front elevation, and instead of dragging this arrow to here, I would prefer to do align to this reference plane, take this top of the legs and lock. Try not to align to edges of other extrusions, always to reference planes. Okay, so with this we complete the solids that we need. Let's go to a 3D view, and now we have a simple table. Let's look at the workflow. So we have created all the geometry. Does it work? We might have made something wrong, so we should test it again. So let's see, let's change some values and let's see if the table responds to the changes properly. We go to family types and we say, okay, how about if the width is, instead of 35 and a half, it's 45 and a half. Apply. Yes, that works fine. Let me put the default 35. And how about if the depth is, instead of 21 3/4, it's 31 3/4? Yes, it works. Let me put the original number again. How about the height? Instead of 17, can I use 27? Yes. 17. And how about if the height instead of 8 is 12? Apply. Yes. So everything is working. So we can say that we tested all the geometry. Now we can move to the other step. Do we need other parameters for the family? Yes, we need. In this case, the workflow says, do you need connectors? No, because this is not an MEP family, but we do need materials. At least one general material to make it look like this. To assign materials for the user, we select the 3 extrusions like this. Press the Control key and select the 3 extrusions. and go to the material parameter and click here, associate family parameter, create a new parameter such as material, make it type or instance if you prefer in this case, and let's click OK and click OK. Now the workflow says, do you need other parameters? Yes, usually you need more information. So you go to the family type and expand this identity data portion of the family types and enter some information about the family. The most basic information is the model number. This is actually a product that you can find in the IKEA website, and the name of the table is Lack Coffee Table. That's the name of the model. For manufacturer, I am going to type simply IKEA. And for the URL, I could go to the IKEA website, get the link, and enter that information here so that the user can click on the family in the project and go and see more information. Let's click OK, and at least these two pieces of information is enough to give you the idea. Our next step, now that we have the object with parameters and we know that it is working, etc., would be to create some types before loading this into a project. So I go to family types, and from here I can create some 3 types. There are basically 2 styles for naming types. One style is to provide descriptive names. For example, coffee table for this one. And then another descriptive name for the second type and another one for the third. That's one way to do it. The other way is to provide the dimensions of the object. For example, we could put first the width in inches, for example, like this, and we say 35.5 W for the width, and then times 21.75 of an inch, and D for depth, plus 17.75 height with shelf, for example. This could be another way to name this type. So if you use this style, just make sure that these values match the dimensions that you have. And if you need another type, you simply go here and create another type. So let's create another simple type with simple numbers such as 16 by 16 by 16 without shelf. So this could be our second type. So for this one, just to keep things simple, I'm saying that the depth is 16 inches, the height is 16, and the width is 16 as well. And I say without shelf. Well, if I want to do this, I need to introduce another parameter. So I come here to new parameter and create a visibility parameter or a yes or no parameter. Usually those begin with the word show. So let's say show shelf, and I want it by type, yes. And here for type of parameter, I select yes or no. And for group, I usually select visibility for anything that is this kind of parameter. Let's click OK. And then for this one that is without the shelf, I simply turn this property off. But to make it work, I need to associate the shelf to this parameter. Because if I apply this now, the 3 dimensions will change, but this parameter is not going to work yet. So let's do this. Apply. So that's my new 16 by 16 by 16. But to make it work, I need to select the shelf and come here to visible, yes, and use this button to create an association between the visibility of this shelf with this parameter that controls that visibility. So when I do that, I can come here to type properties and notice that now it says do not show the shelf. We still see it, but in a half-tone color, right? And if we activate this and click apply, we see the shelf in a normal black color. If we don't want to see it at all, we can say no, do not show the shelf, click OK, and then use this option here that says preview visibility and turn it on to see the object exactly as it would look in a project. Okay, notice that now there is something here, a yellow color, and something here that tells us that we are in that mode, the preview visibility. Okay, so let's create one more. Let's go to family types and create this time something such as, let's create a new type. And this time, let's say 16 by 16 by, let's say 48 or 40 inches without shelf. So this is some kind of tall stand, maybe to put a projector on top of it or something like that. So simply we come here, click OK, and change these dimensions. I only need to change the height, 40 inches, and it's without the shelf, so this will remain off. When I click OK, I have my third type. If I decide to use a shelf, I need to be consistent and change the name to be with shelf, activate the shelf, and if I want to, I can change the height of the shelf. Let's say 18 inches, just to give an example. So each type can have different dimensions for all the parameters. Of course, I need to be consistent with the model number and the manufacturer. So let's suppose that these two types are not made by the same manufacturer. So we remove that, and if necessary, we type something else. And for the model number, we can say tall stand for projector or something similar, right? And if we go to the other type, this one, and we click apply to see it, we can change these values, the manufacturer and the model number. This is like a low stand or low mini table, anything that is the model number or the description. So with these three types, I think it's enough illustration about creating those types. Now it's the time to load this into a project. Remember that we have not saved the family. It still says family 3. So this is the time to use this tool, load into project and close, and save the family. Let's suppose that I save it in my Revit families folder and I call this table, just like that. It could be table rectangular, and click on save. And then we can come to this sample project and put these families into one of these spaces. So let's go to the level 1 somewhere here in this space. So let's try that. To place it, we go to Architecture, Component, Place a Component, and here we have our table rectangular. So I'm going to place maybe 3 of these of the same type, and then I'm going to change the types. So I'm placing 3 instances, and then I change the types. This one is going to be the 35 by 21 by 17. This one can be the other 16 by 16 by 16 without shelf, and this one is going to be my 16 by 16 by 40 inches with the shelf. Okay, when I go to a 3D view, camera, and I look at those objects, I should be able to see all 3 of them in this perspective. And yes, let me remove the crop of the view, and here we have the three different types. Let's shade the view, and there you go. This is one of the types, that's the other, and that was the first type we did. For materials, we can select any of the types and go to Edit Type, and because we created a material parameter in the family, we should be able to come here and select a material from the library. Let's say for example this material, appearance. Yes, let's click on this, let's click to that, and let's select this other type and apply a different material if we want, because it is a different type. Okay, could be this one, and this one could be another material, wood, and choose something else. Okay, so all of these have different appearances. There you go. So these are my 3 tables with materials. If I set the view to realistic, I can see the materials with more definition. And suppose that we want to create another type based on one of these types. I could simply click on one of them, like this one. This one is 16 by 16 by 16 without shelf. I could create a version of this with the shelf, like this. Edit Type, duplicate, change the name to be with shelf, click OK, and simply change that property that says show shelf to be yes. Show the shelf. Make sure that the height of the shelf makes sense. Let's click OK. And this is my other new type with the same material. If you decide to make a change to this family after it was saved and loaded into the project, simply select the family and click on Edit Family, or you can go to File and open the file from here. Suppose that you click on Edit Family. When you return to the Family Editor, you can go to Family Types, and let's suppose that instead of assigning a height for the shelf, you want to control the height of the shelf as a simple formula related to the height of the table. Let's suppose that height of shelf is equal to height divided by 2. And click somewhere else. Now this formula applies to all three types. So notice that now that we have the formula, this value is half of height. And if I go to the tallest table, which is 40 inches tall, now the height of the shelf is 20 inches. Also notice that here in the list of types, you have 4 types, including the 3 that you made originally and the one that you did inside the project. So when you click on Edit Family, you get all the types that you have created in that project. If you don't want to get all the types, then in that case you want to open the family from File, Recent Files. That's the difference. Okay, so this gives you an idea of creating formulas. Let's click OK. And now let's do Load into Project and close. It's your choice if you want to save the family with this change or not. Let's say yes, click OK. Then I see this question. In this case, any of these two options will give me the correct height of the shelf. If you want to override other values of the family, you can use the second option. But in this case, the simple override the existing version will give me the updated height of the shelf to be half of the total height. Let's see the sequence of steps that we followed in this video. First, we chose a template. Then we defined the insertion point of the family. Then we created a frame of references. We created dimensions and constraints. Some of them were locked dimensions. Some of them were converted into length parameters. Then we tested that the frame of references was responding to changes in the length parameters. After testing, we created the geometry and constrained the solids to the frame of references. After testing again, we created types in the family, and then we created other parameters such as materials, model, reference, name or number, description, etc. Then we loaded the family into the project and saved the file. Once the family was in the project, we wanted to do some other modifications, so we clicked on the family, used Edit Family to make other changes, and then loaded the family again into the project. Thanks for watching.